My name is Dr. Esther Trufan, and in this video, we're going to explore the basics of crystallization. Crystals are large three-dimensional networks in which ions are connected through electrostatic forces. And this is an example of the alum crystal structure. Crystallization is a technique most commonly used for purification. The more times we crystallize and recrystallize the same material, the more likely it is that we removed the impurities. Because as the crystal lattice grows, each ion can fit in a certain place, and if only the desired ions are moving into the crystal lattice, then the impurities are going to remain in the gross solution. And the more we repeat this process, the more opportunities we have to extract only our desired ions. Crystallization is also used as part of characterization methods. Sometimes simply the look and the shape of the crystal is going to give information about what type of compound we're working with. Other times, the single crystals that are produced in the process, often very small ones, are used in X-ray diffractometry to determine the structure of the material from which the crystal was grown. To approach our experiment, that involved alum and the growth of seed crystals and large single crystals, the first thing that we considered is the solubility of alum varying with temperature. In the case of alum, and as is the case for the majority of ionic compounds, the higher the temperature of the solvent, the more soluble the solute or the solid will become. It's not always the case. There are some compounds like calcium hydroxide that are going to increase their solubility if we decrease the temperature of the water. But those are more rare instances. In the case of alum, we see that as the temperature goes up, so does the solubility. And that means that if we dissolve alum at a higher temperature than room temperature, then we will be able to dissolve more alum than we otherwise could if we only worked at room temperature. This helps us in the way that as the temperature of our alum solution cools down, the excess amount of alum that we were able to dissolve at a higher temperature is going to come out in some way. Now, how it comes out is going to be dependent on the zone in which our solution is going to be. Here we have our concentration and temperature graph, and we see that there are three different places where our solution could exist. The stable zone, which is marked in blue on the bottom right, is where our saturated solution is going to be. If we look at our beaker, the only thing we should see is a homogeneous mixture or a solution that is clear across the board. If we have a solution in the unstable zone, then we're going to see a rapid formation of very small crystals everywhere in the solution. And that is usually what you notice when you cool down your alum solution and then you start filtering it on filter paper. All of a sudden, those very small crystals form on the surface of your filter paper, and eventually it gets clogged and you have to start again. Or you filtered your solution, it's still cooling, and then it produces a whole host of small crystals again. Now, in between the stable and the unstable zone is the metastable zone. This is where if you have a seed crystal in your solution, the seed crystal will grow, but nothing else. In order to grow a really high quality seed crystal that is large enough for you to begin your large crystal growth, you need to be in the unstable zone, but close to the metastable one. And then when you have your seed crystal of substantial size, then you need to maintain your solution in the metastable zone. Now, if that happens, then your experiment is working perfectly. However, if it doesn't, there are a couple ways in which you can help your single crystal grow larger by creating or improving on your metastable solution. And that is, you can remove all the little crystals that are growing in your solution, and that way you are lowering the concentration, moving from your unstable zone but closer to your metastable one. Another way to approach this is to slightly increase the temperature, but you have to be very careful with manipulating the temperature because you can easily find yourself in the stable zone where your material is once again fully dissolved and your crystal disappears. you.